Iron and manganese is removed from water by the principles of oxidation and precipitation along with filtration. So I'm going to show you what happens to oxidize and then precipitate the iron and manganese out and then filter it out. So here I want to look within these red lines here. What we have here is a well that's pulling water out of the ground, and it is high in iron and manganese. And the iron and manganese at this point is in solution, so it's soluble. It has not precipitated out yet. But if we don't deal with these high concentrations of iron and manganese, when they do become oxidized, such as when they come out and they're oxidized by the air in a glass in the customer's home or in a sink or in the bathtub, the exposure of the iron and manganese in the water to the oxygen in the air will cause it to oxidize and then come out of solution and change colors. So what we want to do while it's still in solution, what we do is we oxidize it. And there's a couple ways we can do that. We can use an air compressor and inject air, which contains oxygen, into the flow stream, which would cause oxidation. So we're on purpose trying to get the iron and manganese that's in solution to precipitate out of solution so we can filter it out. So one method is by using air or some form of aeration. Here we have an air compressor, but it could be some other form of aeration where another type of aerator is used to oxidize iron more so than manganese. Manganese typically requires chemical oxidation. So here we have our chemical oxidant. It could be chlorine, it could be potassium permanganate, it could be ozone, but at any rate, some chemical is used to oxidize the iron and the manganese that's in solution. And here we'll just pretend that it's potassium permanganate since our feed line and our feed pump is purple. Potassium permanganate comes in purple crystals, and it turns the water yellow, or turns the water kind of a pinkish color, pinkish purplish, when it's dissolved in the water. But just like the air, the chemical can be injected into the flow stream and it causes oxidation to occur. And that leaves us with this last portion, which is the filter. So here we have a pressure filter where you can see that the water coming out of the well was blue or clear. We added the oxidant, either the aeration or the chemical oxidant, and it caused the iron to turn this yellow rust color. So what happens now is the iron and the manganese that's oxidized will precipitate out, and it will get stuck in the anthracite and sand filter. And then the water passing through the filter no longer has that color, and it turns back to its normal clear color again. So we started clear because the iron and manganese was dissolved in solution. We then oxidized the iron and manganese, so it precipitated out, and the precipitates stayed in the filter, and the clear, clean water then goes on to the distribution system to the customer's home.